In Unit 5, Lesson 3.2, we're going to revisit what it means to have a zero exponent, or what does it mean to have x to the 0 power. Because remember, an exponent tells you the number of times you're supposed to multiply the base, so a lot of times we get confused when they put a 0 there. The first thing they want you to do in number 1 is kind of complete the table of values. So they're giving you x, and they're starting at 4, and they're going to 3, 2, 1, 0, and then they're giving you expression 3 to the x. So for this first table, it's 4 and 81 because they're saying you're taking 4 and plugging it in for x. So 3 to the 4th power is 81. They're getting the 27 here because they're doing 3 to the 3rd power, which is 27. So to complete this output value, you're going to do 3 to the 2nd, which is 9. And then 3 to the 1st power is just going to be 3. And then the biggest question becomes, what's 3 to the 0 power? So before I answer that, I'm going to go and want you to take a look at what's happening from 81 to 27. And then what is going from 27 to 9? Like, what can we do to each one of these numbers that will produce the next number? And it's got to be the same thing that we do to each one, because that's what a rule means. You apply the rule to each one to get you the next one. So from 81 to 27, if we take 81 and you divide it by 3, you will end up getting 27. And if you take 27 and you divide it by 3, you will end up getting 9. 27 divided by 3 is 9, because 9 times 3 is 27. And then if you take 9 and you divide 9 by 3, you're going to get 3. So each output value, if you take it and you divide it by 3, it's going to get you to the next output value. So when we get to this last part, if we take 3 and we divide it by 3, we're going to get 1. And that is why you'll hear a lot of math teachers say a number raised to the 0 power. So in this case, 3 to the 0 is not 0, because you're not doing 3 times 0. It's actually 1, because you're doing repeatedly dividing something. And when you're dividing something, you can't usually get a 0. So we're going to look at 2. They're giving you some equations, and they want you to find the solution to each equation using what you know about exponent rules. Be prepared to explain your reasoning. So let's go and look at this. 9 to something times 9 to the 7th. So 9 to something times 9 to the 7th has to equal 9 to the 7th power. The only way I can do this with exponent rules is to make sure that this exponent is a 0. Because 9 to the 0 times 9 to the 7th is the same as adding 0 plus 7, which is 9 to the 7th power. Let's look at B. 9 to the 12th divided by 9 to what? So 9 to the 12th divided by 9 to something has to equal 9 to the 12th. So I bet you're already figuring out that that has to be a 0, because when you are dividing, you are subtracting. 9 to the 12th minus 0 is just going to give you 9 to the 12th. So this is also going to be a 0. What is the value? So what's the numerical value of 5 to the 0 power? And what about 2 to the 0 power? Well, hopefully you're picking up on the fact that anything to the 0 power is just going to equal 1. And we'll make a quick little proof just to show you that this is going to work out. Let's say I have 5 to the 3rd, and I want to divide it by 5 to the 3rd. So this turns into 5 times 5 times 5 divided by 5 times 5 times 5. We learn that these will all cancel out, and they all cancel out to give you a 1. Another way to look at it is 5 to the 3 minus 3 gives you 5 to the 0, which is just another way of saying 1. We can even look at a simpler problem down here at 2 to the 0. Let's say you've got 2 to the second power and you're dividing it by 2 to the second power. We all know that 2 to the second is 4. 2 to the second is 4. 4 divided by 4 is just 1. And when you divide exponents, you're really subtracting them. And we already know that this has to equal 1. So hopefully you're picking up that any number raised to the 0 power is really going to give you a 1. And this table in number 1 really gives you a good reason behind the pattern and why it results in a 1.